A little bit about myself. I run the data science team at C2FO. And before I get into creating a contemporary risk management system, I have to give you a little bit of background about C2FO so that it makes sense kind of in context. So C2FO stands for Collaborative Cash Flow Optimization. Try to say that 10 times fast, good luck. But basically, we're the world's first market for working capital. So what does that really mean? I like to give this example where you take a company like Amazon, who happens to be one of our buyers, and Amazon has hundreds of thousands of suppliers in their supply chain, right? So say I'm one of those suppliers and Amazon bought $10 million worth of t-shirts from me. Well, typically, terms of payment for such a thing would be 30, 60, or 90 days. But if I'm that supplier and I wanted to get paid early, maybe I need to start a new factory, hire some additional staff, or make some other type of capital investment, I would have to go to a bank or what's known as a factorer, and basically you take a big discount on the nose, something to the tune of 15 to 18%. Well, what if that same day, Amazon is sitting on $5 billion cash and simply looking to make a 7% rate of return? We can match the two up in the marketplace, and it ends up being a really cool win-win scenario where the buyer is achieving their desired rate of return and that supplier is getting their lowest cost of capital available to them, one that they name the rate to for. So yeah, we have some marketing type pictures here that help explain that too. But when you think about this problem on a global scale, there's about $38 trillion locked up in this accounts payable, accounts receivable conundrum. So when you think about if we were able to unleash, that capital, the trickle-down effects that it can have on the world economy is pretty profound. So what I'm actually going to be focusing on today is this notion of WFC, or Water for Commerce. It's an investment fund that we recently started, and it's geared towards small to mid-sized businesses. Basically, we use some of the C2FO data to underwrite these suppliers because we know so much about them. We've been receiving invoices on them for the better part of 5 years on a nightly basis. So if you think about that versus like a static quarterly, balance sheet or cash flow statement, the speed at which and the level of granularity that we have this data is just not comparable to, a conventional underwriting strategy. For investors, it also offers a very attractive risk profile because we're looking at something like a 40-day duration with about 6.25% yield, which is very exciting for some people. So just in case that wasn't crystal clear, I drew this picture where here you have the C2FO market. Let's just say this buyer one here is Amazon, and you have this supplier. Maybe Amazon receives 20% of that supplier's AP or AR from the supplier standpoint, but then they're also doing business with, let's call this a Walmart, a Target, and maybe like a Dillard's or something. So right now, C2FO cannot help them with this additional AR over here, but that's where WFC stands in. Because if they can upload these invoices from these out-of-network buyers, then we can use some of the C2FO data to underwrite them. Why would we want to do this? So you guys have heard about the lending clubs, the Prospers, there are a dime a dozen small to mid-sized business lenders out there. So why are we going through this trouble of getting into this very competitive, very crowded space? Well, we think because we can kind of do it better with some of the data that we have. You guys are familiar with the adage that better data often beats more sophisticated algorithms within a machine learning context. And it can be, that generalization applies in other areas too. At C2FO, we also like to think of ourselves as the champion of the supplier. Helping out those small to mid-sized businesses grow also helps the buyer's supply chain. And that's ultimately what we're there to do. We can do this without rate gouging borrowers, so that's super important. When you look at some of the APRs that are being charged some of these suppliers on some of the other platforms, in some cases they're quite unreasonable. And we can do this with offering a whole lot of transparency for the investors. But none of this would be at all possible without some of the great open source tools that we've used to kind of engineer this system. So I call this slide the sticker table. It should look really familiar if you guys have been out there to the sticker table. But projects like Pandas, SciPy, Dask, stats models, RPy2, Anaconda, Matplotlib, Luigi, you guys can read the rest. None of this would be possible, frankly, without those great tools. So now we're kind of at this point where we need to understand a little bit about risk management. So I've kind of broken down this continuum of risk management. We'll kind of go from left to right. I'll talk about the type of lending risk that we're addressing and the particular tools and methodologies that we've used to kind of mitigate that part of risk. So we'll start with concentration risk. So we think about a given supplier, right? All other things being equal, you should much rather prefer lending to a supplier that has accounts receivable coming from 2, 3, 4, 5, 10 buyers as opposed to one. So we can think about this as concentration risk. So you see here, with a little, pandas foo and stacked area chart action over time, we can get these nice, pretty visualizations, of course, using the latest and greatest color maps from Matplotlib. But C is more of an ideal scenario than A because you can see that their AR is coming in from a host of different places. There's also this notion of junk that we can think about. So you're familiar with junk bond ratings. So when a supplier is getting paid from buyers that are of a higher caliber that we do not deem junk or the street does not deem junk, then that will help out their score inevitably as well. So let's pick on a Payless shoes, for example. Getting paid, having 10 million come in the door from Payless shoes 3 weeks from now is a whole lot different from a Costco, right? So moving on to default risk, and this is kind of the biggest part, the biggest hardest part that we need to address. What is default risk? It's the likelihood that somebody is not going to pay you, over the course of the lending agreement. So in order to address that piece, we use the 5 to 6 years worth of daily invoice data that we have on the C2FO markets to create these really granular forecasts for what a given supplier is going to have coming in the door 30, 60, 90 days from now, so that we can use what we know that they're going to have coming in to kind of offset the amount that we're comfortable lending them over that same duration. So the PyData ecosystem has come a really long way over the last 5 years. But for those of you out there, the econometricians, the economists that have been doing forecasting for maybe 2 decades or so, there are just some things that did not exist in the Python world that have been kind of battle tested in the R world for a while. So we look to kind of use some of those packages, and over time, this project started about 1.5 years ago. So over time, even the last 1.5 years, those projects in Python have come a really long way. But things like autoregressive moving averages, autoregressive integrated moving averages, Surima models, exponential smoothing. We also have been using Bayesian structural time series quite a bit lately, which is quite fantastic, and simple OLS and polynomial regression when applicable. But in order to use those R packages within the context of our big Python pipeline that we orchestrate with Luigi, we needed to use RPy2 so that we could pass pandas data frames to R data frames or R time series and apply some of those models. I'd also like to point out that we're evaluating PyFlux as well right now, which is a really exciting project. So what does that end up looking like? Here you can see a supplier that exhibits a very, very clear seasonal pattern, and you can see the forecast that we make over the next 90 days or the next quarter. To the right, you can see one of our back tests. So what we'll do is, pretend like we couldn't see the last 90 days, fit a model, and then compare that model's performance to the actuals. One of the requirements is that we have at least 5 quarters worth of data to fit on. And basically, we're looking at things like the MAPE and the RMSE to decide, hey, which one is the best model? Because I went through that laundry list of different forecast models before, but how do you know that an ARIMA is more suitable than a Bayesian structural time series over, just an OLS regression? So those are the types of things that we look at during this whole best model strategy process, and then the one that minimizes the MAPE and the RMSE will promote to the forecast that ends up forecasting the next quarter. So here you can see an example of a supplier that has an invoice pattern that's like a metronome, right? These guys are so predictable. They have this very, very repeatable invoicing pattern, and down here you can see a very repeatable adjustment pattern as well. So when I talk about invoices, generally speaking, I'm talking about a positive inflow. When I'm talking about adjustments, I'm talking about a negative outflow. And you see this sort of fancy, sort of cool matplotlib plot here. And I really like matplotlib for, as sometimes the API can be a bit unruly if you're not using like a pandas or a seaborn, but at the same time, it's also really extensible, and you can do really cool things like, throw in these annotations and subplots galore, and, I really like it, and we use it a lot. So another thing that we need to think about when we talk about, default risk mitigation here is this concept of seasonality, right? We can see here that this particular supplier has exhibited some growth over time, and that's kind of broken down into this trend component here. And they also exhibit very regular seasonality that I likened to a metronome before, which is broken down in this seasonal component. And then kind of everything that you have left over is that residual that can't be captured in those two other pieces. But when we're talking about lending, we need to know, is this supplier right at the beginning of a big seasonal period where their AR is going to be on the steady incline, or are they kind of headed towards a trough right now? So breaking down that seasonality and understanding where they are in that cycle is really important for us. Now I'm going to talk about this idea of AR discontinuation. Later on, I'll contrast it with this notion of bankruptcy, but this is where we are for the moment. So when I talk about AR discontinuation, think about like flatlining at the hospital, right? Your pulse, you just cease to, your heart stops beating. When we think about cash flow with the buyers in the C2FO network, that's what I'm considering AR discontinuation here. The likelihood that they will completely flatline across all of those buyers in a given duration of time. So in modeling that out, it's not super easy, the whole 80-20 rule, blah, 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 with data preparation. We needed to be very sure that we weren't having any data leakage. Effectively, what you have to do is go back and say, okay, if we wanted to predict this on this date, realistically, in order to not get into a lending agreement with a supplier that may be up to 90 days, you need to know 90 days before that what the likelihood of them discontinuing invoicing would be. So you have to kind of chop off that history prior to the date that you would be making a loan, and then train your models based on that truncated history. So we were very, very cognizant of this data leakage problem along the way. And then briefly, talking about engineering interesting features, I like to think about feature engineering in this context kind of three different ways. You can create these really interesting, aggregate stats kind of based on their entire history. What was their median this, their min that, their max this, or, then you can think about over a certain recent window, like maybe a 13-week window or something like that, calculating all of the same stats. And then maybe you want to look at what was it right at that point of time that you would have wanted to make that prediction. Oftentimes, when you break apart the feature importances and start introspecting some of these models, you'll see that it's an interesting mix of these historical features, these near real-time features, and some of these windowed features that kind of bubble up to the top. So I just encourage you guys to explore different windows and things like that during your feature engineering process in the future. So how do we do all this? I used scikit for most of the feature engineering for things like encoding categoricals and creating polynomial features, in addition to scaling features and reducing that feature space using dimensionality reduction and feature selection techniques. As far as the models were concerned, we had a host of different models that we tested, but shocker, XGBoost ended up outperforming the majority of them. So XGBoost, an implementation of gradient boosted trees, very performant machine learning classifier, yada, yada, yada. There was a talk just a second ago next door, and a talk yesterday. It kind of touched on grid searching your hyperparameters. But when we used XGBoost, we were using the hyperopt library to optimize that hyperparameter grid search. And we're also currently in the process of evaluating a library called Spyre that does some Bayesian optimization there as well. So I'm really excited to kind of get into that as well. So when the rubber hits the road, how'd this thing do? We're really concerned with two things in training these AR discontinuation models, namely recall. So what percentage of those ones that actually ended up flatlining did we end up catching? And you can kind of see in this plot how the performance has generally improved over time. Some days it goes down a little bit. This big dip here is explained by some new features that I ended up adding, which drastically improved the performance of the model. And not overfitting. So, I could give a whole talk about overfitting, but when you're using a classifier like gradient boosted trees or something like that, you really, really need to understand this overfitting problem and make sure you're not doing it. So that's AR discontinuation. Cool, got it. We don't want those suppliers to flatline. But then there's this other problem about bankruptcy. So when you think about bankruptcy, sometimes somebody can file for Chapter 11 and they continue to pay their bills. Sometimes they file and then they don't. Sometimes they file because their management team had a big falling out. Sometimes they file because their business just wasn't viable. So it's kind of a different thing versus ceasing to invoice with a particular buyer versus some other type of nuclear event that caused them to throw their hands in the air and say we can't pay. So we created two separate models to understand both of those things. But in training a model for bankruptcy, we needed to figure out, hey, who went bankrupt? And turns out doing that isn't always like the simplest thing. We had to ingest all this data from a national bankruptcy database, for those of you that are familiar with Pacers, and then match it up with some of our in-house company names. But oftentimes the two aren't going to say the exact same thing. So there's like this interesting matching problem that we first had to tackle before training these really fun models. And actually I was talking to Mike Molt earlier about a talk that he had given in the last, I think it was like a year ago or around that time, for doing some of like this, addressing some of these fuzzy matching problems with string matching. And that was just tremendously useful in figuring it out for ourselves. And we kind of came up with our own in-house approach that made sense for us and delivered on some of the requirements that we had. So I'll walk you through that real quick. Of course, we have to clean our data, convert things to lowercase, remove special characters, all that fun stuff. Then I want to do the easy stuff first. So string matching and geodistance, great. That stuff's hard and less, there's some uncertainty baked in there. But if I have a tax ID on both sides of the fence, I'm going to use that. If we have a phone number on both sides of the fence, I'll use that. Then we get into, okay, well, this is Tom's Hardware and this is Tom's Hardware without the apostrophe, LLC or something like that. How do we know if those are the same thing? Well, we can use all these different string matching techniques, things like Levenshtein distance, things like Yarr-Winkler distance, things like Jacquard distance, and there are lots of others, but those are the three main ones that we used. And then one thing that we also employed in this kind of hierarchical matching approach that I thought was kind of unique is just looking at the geodistance between these two different locations. Say one is on Main Street in your town and the other one's in Wilmington, Delaware, a city where a lot of LLCs are incorporated. How do we know if that's really the same thing? Basically what I did is after going through like this string matching process, I allowed the geodistance to have kind of a multiplicative effect on that score and kind of help us increase our confidence that it's actually the same person or the same business entity. So a little pro tip, quick tip down here, things like if you're rolling your own for something like Habersign distance or something like that, think about doing it in Python first, because without a great level of effort, you can do that, and it's going to be so much faster than if you implement it in pure Python. I'm sure you guys already know some of that. A lot of people have touched on Python, throughout the last day. And numba for if you're doing some, NumPy operation or something like that. It's really easy to wrap that in a function, add your JIT decorator, and then you stand to benefit from the just-in-time compilation there. And we've benchmarked these things, and it's a big speed up in a lot of cases. So what does that end up looking like? So you can see some different companies here. One of the name that came up on the bankruptcy, and then the name that we had on file, and some of the string matching stats and the geo distance, and then the score that they ended up with. So this is an interesting one. Innovative construction solution, NorCal versus innovative construction solutions. Very similar. Obviously, geo distance comes into play. Maybe this is like a branch or something like that, but we felt pretty comfortable saying, hey, this is the same entity. So just a quick fun fact about bankruptcy as it applies to some of C2FO's suppliers. A lot of conventional wisdom kind of comes out here when you see things like eating places and hotels kind of bubbling to the top as some of the most common businesses that end up going bankrupt. And it's interesting to pick apart this trend over time. Generally speaking, you can see that fewer businesses now are filing than were in 2009 and 2010. Then when we look at this heat map of the employee count on the x-axis and then the company sales on the y-axis, perhaps you could draw a conclusion that's a little bit discouraging for an aspiring entrepreneur, and that is smaller companies with less sales end up filing for bankruptcy more often. Shocker, right? But you actually see some of the bigger boys down here in the bottom right-hand corner filing too. And I apologize for this terrible color map. People on my team know that I'm like a total stickler for visualization and stuff, but no other color map really kind of highlighted these differences over here as well as this one did. Anyway, moving on. So now we need to talk about fraud risk. How do you know that this supplier that you're about to engage in this lending agreement with is, for lack of a better term, a good actor? Okay, how do you know that they're being honest? Well, we need to be able to sniff that out. And in order to do that, we employ a couple different tricks. When I say tricks, I don't really mean tricks. But when we call up these suppliers and we kind of pitch them on this idea, hey, would you like this, really affordable loan, blah, blah, blah. This is how we underwrite you. You just need to upload these other invoices from some of your out-of-network buyers. We're recording those phone calls and we're running some natural language processing in the background. And once we have that transcription done, then we can use awesome libraries like Spacey to do some of the lemmatization, tokenization, et cetera. And we can do very simple things like pick out words that we deem potentially troublesome. Things like debt, leverage, bankruptcy, lien, divorce, alcohol, rollover, audit, Cayman Islands, right? These are words that you do not want to have a high occurrence of in some of those calls because it may be indicative that they're not actually as good of an actor as you would like them to be. So a pretty simple technique, but again, very helpful. How am I doing on time? 15 minutes? Good. Long story short, this wouldn't scale if we had somebody sitting there doing it themselves. So this is something that we wanted to figure out early on. Another way that we are kind of de-risking these suppliers from a fraud standpoint is this notion of invoice congruency. So that's to say that we're asking these suppliers to upload their out-of-network invoices, but on the other side, we have the invoices that the buyers in our markets uploaded. So we can actually compare them in terms of amounts so that we can see, hey, what they're uploading, is it the same as what that same buyer was showing us? So we know that they're not padding their invoices. So, sorry, I kind of went through that pretty quickly. I know I have about 7 minutes left here, so I want to... 25 minutes. Oh, wow. We can spend all the time we want on this stuff. But, having a conversation with somebody and, actually seeing those invoices, but having a source of truth, like the invoices that we're seeing from our Costco market or Amazon market, turns out to be a really good way of saying, hey, is this particular supplier trustworthy? When you think about what maybe a bank is relying on, or maybe another lending platform, these are things like unaudited financial statements that, one, are static, right? So it's going to be like a quarterly statement from so many months ago that probably didn't undergo a rigorous audit, and two, so there's the piece that you can't vet well, and then there's also this piece that that was a fixed point in time. How does that speak to their ability to cover the terms of that loan within this applicable duration? So the information that we have, hopefully it's pretty intuitive by now, helps us control some of these risks. So the last area that I kind of want to talk about is portfolio management. So once we have all of these suppliers in our portfolio that we're willing to engage in lending agreements with, based on the fact that they have diverse cash flows coming in from a bunch of different buyers, and we know that they're not going to default or go bankrupt in the next 45 days or something like that. And we've established that they're a good actor based on the fact that their invoices match up dollar for dollar with what our buyers are uploading, and that they're not saying words like alcohol, divorce, and Cayman Islands, 5, 6, 7 times during the course of a phone call. We get all these suppliers in the portfolio, and then we need to think about, okay, well, where should I establish their credit limit, and at what rate should I be charging them to borrow that amount? In order to answer those two questions, we arrived at what we call like a WFC score. So you guys are all familiar with your credit score, right? A WFC score is basically on a scale of 0 to 100, where we look at the amalgamation of these different risk factors that I just talked through, and we come up with our opinion about how trustworthy and how good of a prospect for a lending agreement that particular supplier might be. So here you see two distributions, and we apply kind of a trick to arrive at one of them. So this first distribution is all of the suppliers that met all of our criteria. If you recall, before I talked about requiring up to 5 quarters of historical information to make those forecasts. But what about the suppliers that are relatively new on the C2FO platform that we don't have that much information for? I'd still like to appoint them with a score, but since that's one of the underlying variables, we're just missing in some cases. So the trick was to train a classifier, right? We have all of this other information on them, and we have this like subset of the population that is scored. Okay, those become our labels. That WFC score is just a continuous variable that we're trying to predict, and then we can use everything else that we know about them to kind of validate that score. So we're looking at an error range of like plus or minus like 8 points or something like that, and within the context of what we were trying to do, that met certain business requirements where we were comfortable enough imputing some of those WFC scores with that strategy. And that gives us complete coverage with all of our hundreds of thousands of suppliers in our network. So sometimes when you think creatively about how data is missing or something like that, oftentimes you can get to a pretty good solution if you're just kind of objective about the problem from the get-go. So talking about calculating limits. So the way we calculate our credit limits, you remember those forecasts that I showed you before. Let's just go ahead and say that somebody has 20 million coming in the door over their next 60 days or something like that. If they're in a top decile based on that WFC score distribution, then maybe we'll say, okay, we're comfortable lending up to 80% of the cumulative sum of that forecast over that duration. Okay. If they're in like a bottom decile, well, maybe we won't even touch them. We won't prospect them for a loan. But if they're somewhere in the middle, maybe we're not comfortable going up to 80%, but maybe we're comfortable going up to 40%. I won't tell you explicitly what those ranges are, but it's kind of an intuitive idea. The more trustworthy they are, the more information we have about that supplier that can yield some kind of competitive advantage for underwriting them, the more comfortable we are giving them a higher credit limit. What's really interesting about how we set rates, we have kind of two different strategies for doing that. Within the context of the C2FO markets, we constantly have these suppliers bidding in terms of APR or discount what they would like or the discount that they would be comfortable with to accelerate payment on their accounts receivable. So we can kind of use what some of their bids are within the C2FO markets as a baseline for what their true cost of borrowing might be. In some cases, they're a little bit riskier than what they're bidding in the C2FO market, so we can adjust for things like that. And in the event that they have never placed a bid in the C2FO markets, that's when we start talking about portfolio management theory and convex optimization problems to arrive at what the appropriate rate should be for a given supplier if we want to manage a portfolio with a risk profile that looks like this or like that. But those are kind of the two approaches. But the fact that we have this really interesting information from flowing through from the C2FO markets that may be indicative of what their true cost of borrowing is really allows us to, let them borrow at rates that just wouldn't be possible at other banks or through other lending platforms. So then we think about who should we continue lending to? So once you're in the portfolio, great. You kind of checked all these different boxes according to our WFC underwriting criteria. But just because you're in the portfolio doesn't mean, and you repay your loan, doesn't mean we should, keep re-upping with this supplier and continually engage in more and more lending agreements with them. So we look at things like level shifts in their accounts receivable patterns. One of my colleagues, Eric Bunch, later today, he'll be talking about level shifts, a package that was initially developed by Twitter for detecting level shifts in time series, has been ported over to Python, and he'll walk you through that a little bit later today. But suffice it to say that we look for interesting jumps in their time series of accounts receivable to indicate that something has changed, something has fundamentally shifted here that we need to be mindful of and perhaps re-underwrite, re-evaluate, et cetera. We can look at changes in the C2FO markets. So if one day somebody's bidding at 8% and then tomorrow they're bidding at 18%, perhaps something changed overnight. What's the saying in Super Troopers? Desperation is a stinky cologne or something like that. If we interpret that bid change as a sign of desperation, that is a very, very early indicator that maybe we need to rethink this thing. WFC score changes, very intuitive there. If some of the variables that we underwrite on shift over time, and we see that WFC score moving around, if it has a high volatility or if it goes from 80 to 60 one day, that's something that's going to be a big red flag for us. Adjustments. I mentioned before, those are negative outflows. So when you see an unprecedented adjustment and you kind of wrap like a business understanding around that, maybe that means that a buyer is returning a bunch of their goods because they were defective. Maybe that means that something else in that relationship went wrong. Adjustments can signal a lot of different things. Sometimes they're just business as usual, but we're paying attention to the adjustment to invoice ratio so that when we do have unprecedented adjustments, that raises some red flags. And then we also have some other interesting signals like buyer reserves. I don't want to get into too much detail about buyer reserves, but long story short, sometimes a buyer will reserve the amount of accounts payable that they will allow a supplier in the C2FO markets to accelerate, and they do so for different reasons. But when you see a buyer like Costco who goes from like a 10% reserve to like an 80% reserve on a supplier, like something changed there, and maybe that's an early signal of distress as well. That WFC score over time, I mentioned that we're tracking it, obviously. So you can kind of see here the time series of that score on the bottom subplot. In this case, it looks like they go from the mid 70s up to like the low 80s on some days, so not a ton of movement. But you can see, like their invoice discontinuation probability over a 45-day window, like it jumped down on this day. So maybe like there was a big adjustment that came through or something like that, and the model picked up on it. can see here their junk score went down quite a bit. So that meant that a higher percentage of their accounts receivable was coming in from a supplier, or a buyer rather, that we deemed junk, by virtue of having a low bond rating or something like that. So standing way back for a second and kind of reevaluating the whole big picture here of risk management, we talked about concentration risk, we talked about default risk, fraud risk, exposure risk in one way or another, and some of the unsystematic risk that you face when you are managing a portfolio of diverse suppliers that you're engaging in lending agreements with. Things that I didn't mention along the way, we talked about how Pandas was great for cleaning up those time series and panels, and how we can pass Pandas data frames to RPy2. We talked about how stats models makes things like seasonal decomposition really easy. We talked about how scikit is useful for feature engineering, and how we can use libraries like XGBoost to train highly performant classifiers. But I didn't really talk too much about like the Anaconda distribution and how easy that makes certain things. And I didn't really talk about the extent to which this is all built on a very, very complicated pipeline that has to run every single evening, accounting for new invoices and adjustments, looking for the latest and greatest bankruptcy information, retraining models, tying all of these different pieces together to arrive at our very unique opinion about whether or not the supplier is worth lending to. And the other quick shout out here is Dask. We're reevaluating the entire code base to look for areas that kind of lend themselves to out-of-core parallelization with Dask, and we've already found a couple different opportunities, but in time we'll look to incorporate that in a lot of other ways. So here you can kind of see what our Luigi DAG, or directed acyclic graph, looks like. But I would like you guys to consider something for a second. If we were to turn it upside down, right? You guys are with me? What does it look like? Maybe kind of a cobra in a basket? I don't know. You tell me. But just in the theme of Anaconda, Python, etc., I'm considering renaming this project internally Cobra, which sounds pretty cool. So you be the judge. All right, cool. I talked about a lot of stuff. Demo time. So this is what the web app looks like. For those of you that are familiar with R Shiny, a really simple and intuitive web interface for interacting with your data. And there was this really cool project that started off called Data Spyre. Now I think it's just called Spyre, that uses Cherry Pie and Jinja 2 behind the scenes, and is just super maintainable for data science. We have like a very nice front end that the core C2FO product uses, and a very nice front end for the WFC product. And we have a lot of really talented Angular developers and things like that. But for this tool, the onus was on the data science team to build it and maintain it. So I'm not a front end guy personally. So I wanted to use something that was easy to understand, easy to maintain, etc. And Spyre just checked all of those boxes for us. So allowed us to do some simple interactive things, but also maintain the code base and not go crazy. So just things like formatting data frames down here, showing our sweet matplotlib forecast up here, looking at our forecast, the seasonality plot that I mentioned before, the decomposition, that buyer breakdown, so you can see how diverse their accounts receivable are, their historicals, historical WFC score rather, some supplemental information like, okay, this particular supplier manufactures ice and was started in 1998. And then the whole ranked list here of all the different suppliers. So you could just grab one, drop it in here and look it up. And then if you wanted to see what their credit limit would be, you would just adjust that window for the duration. Things would recalculate. Of course, it's going to be painfully slow over my hotspot. And then you can see here that the credit limit has adjusted based on that new duration. And then if you wanted to download a spreadsheet that kind of encapsulated all of this in just one kind of nice, neat picture, we could go ahead and do that. That wasn't too bad. And you have all of that information in one place for bookkeeping purposes. So quick, easy, cool, practical, all of those things. So what? I like to end kind of all of my talks and meetings with this idea of just so what? I talked about all this stuff, but at the end of the day, what does it all mean? I think objectivity is really important. So we tried to approach this this lending problem from a completely objective place. We didn't want to build off of any of the things Lending Club were doing or any of the other guys. We wanted to use our data in a way that was novel and purposeful for the ends that we were trying to achieve. And I think things are working out really well so far. You've heard it before, but better independent usually beats more complex algorithms. The feature engineering process, can't stress how important that is, and the whole modeling process. And I encourage you all to come up with new and interesting ways to engineer those features. We talked about how Python and Numba can be used to, with very little effort, can be used to speed up your code drastically in some cases. So somebody might have said, oh, why didn't you write this system in like a Go or something like that, or why didn't you write it in C++, or like an OCaml, like the Jane Street guys might have. Well, again, we wanted to kind of play to our strong suits. We needed something that was performant, and Python kind of checked those boxes for us for our particular problem. I mentioned that WFC is a win-win for borrowers and investors. The yield that you can achieve as an investor is very attractive, and we're giving loans to suppliers that could not be borrowing at that low of a rate from a big bank or from some other lending platform. And when you think about, you're helping those businesses grow, that's a really cool thing too. Always be mindful of trade-offs. When you're engineering a system, a complex system especially, from the ground up, how fast is fast enough? Would I want to maintain this code a year from now, 2 years from now, 3 years from now? I talked a little bit before about, do you need a beautiful front end or something that's simply functional and readily extensible? These are all things that you really need to, look deep within yourself and ask before creating a ton of technical debt. And last but not least, creating great solutions with open source is part of open source too. Sometimes you can get really caught up on, obviously to keep the community alive and well, you need people actively contributing and cross-pollinating ideas, but you also need to be building really great things using that software to kind of keep the momentum and the trajectory headed in the right direction as well. So with that, thank you very much, and I'm here to answer any questions that you may have. Yes?
So two questions. One is for your look-ahead bias. Like, what do you guys do to deal with that other than being so conscious of it, using the event libraries or whatever? And then the second part, and you haven't really touched on that at all, you obviously have a lot of sensitive data about a lot of companies, like how do you deal with things on a security side?
So the first question was, how do we address kind of look-ahead bias? So I'll talk about that in two different lights. The first piece is kind of with those forecasts. So we want to create this great forecast for the next 90 days. So what we'll do is pretend like we didn't see the last 90 days, train a model up until that point, and then evaluate all of these different forecasts against what actually came to fruition over the course of those 90 days, seeking to minimize the things that I mentioned before, MAPE, RMSE, etc. So whichever model kind of minimizes those things over that backtest period will promote to the best model for the next 90 days. So within a forecasting context, that's kind of how we think about it. So with the AP discontinuation stuff, or the AR discontinuation stuff rather, similarly, if we wanted to make a prediction today, or if we were going to engage in a lending agreement with somebody today, ideally we would like to know 45, 90, 180 80 days in advance that their likelihood of discontinuation is high. So we would truncate, that window of time, and then we would train our models based on, that which would have been observable at the time that we would have liked to make that prediction, so that we wouldn't have engaged in a lending agreement with them within that window of time. So it's kind of like hiding what wouldn't have been observable at the time.
Sounds like you didn't use anything special, because I usually need to do that too, but it's just so easy to have like data leak in, and you have something wrong, and you do like a shift plus instead of minus, or whatever you guys use to kind of get the forward-looking data. But it sounds like you just kind of made sure like you didn't use any tool.
No, I did write some gnarly functions to do that for us, which I would be glad to share if they're useful. But basically, something like you would pass in a time series, you would pass in like a window, a prediction window, like 45-day window or something like that you need to truncate that data. Then it does some injection in like a SQL query and allows you to get that data back in a nice kind of clean panel with your class label based on what actually happened over the course of that prediction window. I'm trying to make it a little bit more universally usable. And that's something I'd like to open source over time if it would be useful. And then I believe you had a second question as well.
Yeah, the security aspect.
Oh, the security aspect. Yeah. So our suppliers' data is very, very important to us, and I made a point to obfuscate everything related to those suppliers so that we can keep that private as it should be. But at the same time, that same information is very useful for us for prospecting some of these suppliers and giving them the opportunity to borrow at these very agreeable rates. So yeah, it's of the utmost concern always to keep that data private as it should be. All right, if there are any other questions, I'd be glad to talk to you outside, and just like to thank everybody again. Thanks.